Hello, in this lesson I want you to use line symmetry to describe reflections that carry a figure onto itself. And I want you to use rotational symmetry to describe the rotations that carry a figure onto itself. So we're going to be looking at symmetry, line symmetry, line of symmetry, rotational symmetry, the center of symmetry, order of symmetry, and magnitude of symmetry. You're going to find out this is very, very similar to everything we've been doing. The only thing that makes symmetry different than what we've been doing is exactly what I said is what I want you to do today, is it takes an object and it maps it onto itself. You're not going to get a new object. You're going to get an object that maps it exactly onto itself. If you have a line symmetry, there's a line, you're going to reflect it across, and every point maps onto a point onto itself. That's what it's called. If we take a look at our examples here from 1 through 3, I want to state whether there appears to be line symmetry, and if it is, I want you to draw in all the lines of symmetry. Well, if I take a look at example 1, it looks like it's very symmetric. You can kind of see from the pictures there, it's very symmetric. Kind of an Asian type of, Indian type of drawing. And that's actually makes sense because in the Muslim faith, since they can't take pictures of each other or of, like we have pictures of Jesus, there's no pictures of Muhammad. What they do is they have different types of symmetry that they draw shapes onto themselves, and that's exactly what we have here. So if we take and I'm going to just draw my line. There's one line. It looks like through every point there is a line. Get it nice and straight there. How about? Do I have them all? Oh, I got missed one there. There we go. So every time I reflect over each line I've drawn, I'm going to get the same exact shape. So that's a line of symmetry. There's 7 because we have 7 points. And then the answer is yes, I guess. Now, if I take a look at number 2, it looks at first like it might be the shape, but notice those patterns inside make it kind of hard. There's no corresponding shape in any direction here. So I would say there is no lines of symmetry on this one. And now let's take a look at one more on the next page. And it's kind of like on the first page that I can draw in these lines, and they're going to match up to each other there. Whoa, that was kind of curvish there. Let's get it back straight. I got too much there. Let's try that again. Now notice every point goes to every point on this one. So there are 5 lines of symmetry. So yes, it is if there are 5. Now, if we take a look at rotational symmetry, it's exactly what it sounds like. I'm going to turn it, and it's going to map on exactly onto itself. There's a center rotation. That's the point I'm going to turn it through, usually in the center. It's got to be less than 360 because we think everything maps onto itself in 360. Now, when we talk about magnitude, it means how many times can you turn it by less than 360. So like on this shape, I would say it has an order of magnitude of 4 because I could turn it 4 times and it maps onto itself. So if I take a look at this one, I want to locate the point of symmetry, the center of symmetry, if there is one. I want to state the order and the magnitude. And identify if the shape has point symmetry. Now, point symmetry is a little bit different than rotational symmetry. Point symmetry is 180 degrees. That's what point symmetry is. So if there's a shape exactly opposite it, every point has a point exactly opposite when you rotate it, then there is point symmetry. Otherwise, we would say no. So there, on this one, on example 4, this star, there is rotational symmetry, isn't there? And there's my center. And when I look at this, I'm going to turn it 5 times. So the magnitude is 5. Or the order is 5, I should say. The magnitude is the degree. So the magnitude is 360 divided by 5, which is 72 degrees. Now, is 72 a factor of 180? No, it's not. So there's no point symmetry on this one. Also, you can tell there's no point symmetry. So if I pick a point and I do 180 degree rotation, I don't have a point exactly opposite that. Now let's take a look at problem 5. That one appears to be, looks like I could turn it 3 times, right? So I'm going to say the order equals 3, because I could do it 3 times. So the magnitude is 360 divided by 3, which is 120 degrees. That is not a factor of 120, so there's no point symmetry. Now if we take a look at the next one, and once again I've got my center rotation right here, and as I go through this, it looks like there's 1, 2, 3, 4, 5, 6, 7, 8. I could rotate this 8 times and have it be the same. Now the magnitude then is 360 divided by 8, which is 45. Notice that is a factor of 180, so this one does have point symmetry. And we can kind of tell that if I take this point and I go 180 degrees, there is a corresponding point opposite it for each one. And that's where we get that from.